This machine can make gradients with 3 colors, and by using gravity blocks you can build good looking walls really easily. And you can also change some settings on the machine to make completely different patterns that sometimes uses more than 3 colors. In this video I'm going to go over how this machine works, how to use it, and how you can change some settings to make different patterns. I've started designing this gradient placer after seeing the one by Arnaud that we built on a Chrono server, and his machine was doing vertical gradients of multiple colors, but it was only doing a gradient between 2 colors at a time. And so I decided to take a look at the logic and see if I could make a gradient using 3 colors. And so that's why I started working on this back in September. And recently I've took a look at this machine again and I improved it a lot. Now it's a lot smaller. So as I said, the goal of this machine was to make a gradient between 3 colors. In this case we will start from the red to orange and then to yellow. So we need to begin with only red, then start implementing the orange, have more and more of it, start implementing the yellow and have less and less red. Then at some point we will even remove the red completely and have only yellow and orange to have more yellow at the top. And this is the logic that we need to handle with the machine. But there is a slight issue, is that if we hardcode the transition between the 3 colors, then all the slices will be the same, and so we need to have some sort of randomness. The randomness is important because that's how each slice is different, and this is how we can create a smooth gradient. And just to be clear, since we're using gravity blocks, we are building one slice at a time, from the bottom to the top, and once we reach the top, we start the new slice. So the logic is the same for each slice. To introduce a randomness in the gradient, I'm gonna use shulker boxes with different fill level. And this is an idea I took from Arnaud's design. Each shulker boxes gives a signal strength between 15 and 1. And then by using this system, which is a design by Floppy I believe, we can dispense the shulker boxes randomly, because the dispensers and droppers are completely random. And each time we activate the machine, it will dispense the shulker boxes for only 2 game ticks and then break it again. Okay, this is cool, but how can we create the gradient now? To explain that, I have added a few things to the machine, and I will start by explaining how to make a gradient with 2 colors because it's a bit easier to explain. So this comparator, which is reading the box, has a signal strength on the side, and this signal strength is stored using 2 comparators, and here I have another comparator with a compressor with a signal strength of 1. So each time I activate this piston, the comparator will read a signal strength of 1 and it will retract 1 from the signal which is stored here. So now we have 14, and each time I press this note block it will go down by 1. When we start the system, we start at 15 here, and I will start the clock. This will work on a 6 game tick clock. And if I add a lamp here, we can see how often this comparator turns on and it never turns on, because the signal strength on the side is 15 and the maximum that this can read is 15. And this comparator is on subtract mode because the lamp is turned on, and so it will always subtract the signal strength it will read by the signal strength on the side. So since the maximum is 15, if you subtract 15, it will always be 0. But now if we reduce this by 1, we have 14. So if it reads the shulker boxes with a signal strength of 15, then it will output 1, because 15 minus 14 is 1. And so then the lamp will turn on. So the lamp will turn on once every 15 boxes. And if we reduce the signal strength on the side, now this comparator will turn on if the shulker boxes have a signal strength of 13, 14 or 15. So 3 out of 15 times. So now the lamp turns on more often. And so every time a shulker box is dispensed, if the lamp doesn't turn on, we will place the first color, and if the lamp turns on, we will place the second one. That's why in the beginning we only have the first color, then we start having a bit of the second one, and the more we reduce this, the more of the second color we will have. And if we go all the way down to 0, now we only have the second color, because the lamp is always on, since this is always 0. And so that's basically it. As you've seen, it's not really complicated. But now if you want to add a third color, it gets a bit more interesting. Now you can just check when the comparator is on or off. You also need to check its signal strength when it's on. I added another lamp and it's connected to the comparator here, and this lamp will only turn on if the signal strength is 7. I've resetted the system, so while it's 15 here we'll have no signal, and if we start going down we'll have the second signal, which is the second color, and this is still the same, but here as you can see the signal strength is 1 or sometimes 2, but it's not strong enough to reach the second lamp. To reach the second lamp the signal strength needs to be 7, and so this signal strength here needs to be 8, because 15 minus 8 is 7. So if we go down to 8, now we can start to see this lamp turn on, but only one every 15 times. And the idea is that if the second lamp turns on, it will override the first one, and we only dispense the third color. So if the comparator is off, it's the first color, if the first lamp is on, it's the second color, and if the second lamp is on, it's the third color. So again, this is not really complicated, but now we'll have to see how to make the logic. Before showing you the logic, there is just a slight issue that we need to fix, and this is that the comparator here is only turning on for 2 game ticks. If I turn on the clock again, we can see that it only turns on for a short while, meaning that if you have another comparator here, for example, it will not turn on. If you have a block and another comparator here, it will turn on, but then again, this one will not. You can have a dust and it will work, same if you have a block, but you can have 2 comparators next to each other. Well, you can if you add more, but then the last one will never turn on. And there are different ways to deal with that. You can use observers to prime the comparators, but I think the easiest way here will be just to extend the signal. So you can transform the signal into a 4 game tick signal instead of 2 game ticks. And I don't think I mentioned it yet, but this system is working on a 6 game tick clock, because this is the fastest you can have when you're working with gravity blocks. Otherwise they will break if you place them too fast. And so to extend the signal, I just added 2 comparators here and 1 here. And now this dust will turn on for 4 game ticks instead of only 2. Now that we have our signal, we want to separate it into the 3 colors. So first we'll have a set of comparator here with a signal strength of 2. So by default, if there is no signal, the signal strength at the output will be 2. And here I will have a comparator with a signal strength of 1 this time. And so if I have this comparator in subtract mode, if the signal strength is 1, it will reduce it to 1, and here we'll have 1. If the signal is higher than 1, this comparator will turn off, and only this one will be on, and so the output will be 1. So basically, if the dust is off, the output will be 2, and if the dust is on, the output will be 1. So we have 2 different outputs for the first 2 colors, and if we want the third one, we'll also have to turn this comparator off, and so this will be 0. For that we can redirect the signal into this comparator to turn it off, but we want this one to only turn on if we have at least 7 here. And so we can have another comparator and a barrel with a signal strength of 7. So if input is 0, the output will be 2. If input is between 1 and 6, the output will be 1. And if the input is 7 or above, the output will be 0. And there we have our 3 colors depending on the signal strength. The next thing we can do is to invert the signal. So instead of having 2, 1 or 0, we'll have 1, 2 or 3. And for that we can just have a comparator on subtract mode and a signal strength of 3. And so here 3 minus 2 is 1. If I turn the system on, I have 0 on the side, so we'll have signal strengths between 1 and 15. We can check the input here and see what the output looks like. And now that we have our signal strengths at the output, it's pretty easy to connect it to a red color to select the correct color depending on the signal strength. But I will show you that later because I want to add another thing to the logic. In this case, if we go from 15 to 0 here, we have 16 different steps. But there is still one thing that I don't really like, is that we have the third color coming when the signal strength is 7, so roughly halfway, but we have the fourth color staying almost until the end. And my idea to fix that was to add some signal strengths after we reach 0. To hopefully make it a bit clearer, I wrote down the sequence. On the left we have the signal strengths that we subtract or add to the comparator. So this corresponds to the signal strengths here that we subtract from this comparator. In the middle we have the signal strength that we get at the input, and so this is this input here. In the beginning, since we have 15 on the sides, we will always have 0. As we start reducing the signal strengths, we will have 1, 2, 3, up to having a signal strength from 0 to 14 when we have 1 on the side, up to having between 1 and 15 when we have 0. So this is what I've shown you here. And on the right we have the colors that correspond to the signal strengths. So first only red, then red plus orange, and then we start having the yellow at 7, and at the end only orange and yellow. And this is the issue that we want to fix. We want to remove the red sooner. And to fix that, I want to add 4 more steps where we will add some signal strengths. So we will add 1, 2, 3 and 4. And so at the input, we will have between 2 and 15, 3, 4 and 5 and 15. And this will result to having only orange and yellow, and also having less orange and more yellow at the end. We could technically add more signal strengths here, but I found that this is a nice balance and we have 20 different steps, which makes it easier to configure the machine. I moved this part of the system a bit and I will show you how you can add signal strengths. So we'll go from here, and first you need to invert a signal. So you can use a resonance block to have a signal strength of 15 and have the comparator in subtract mode. Then you can have another comparator here, and this is where you will add the signal strength. Because you can't add a signal strength from a comparator, you can only remove it. And so if you have another comparator here and some containers, you can, for example, decide to have signal strength of 2, and here you will have 15 minus 2 is 13. And then if you invert the signal again, you will have another comparator with a signal strength of 15. I'm adding 2 just, otherwise this resonance block will cancel this comparator. So if we have also this one in subtract mode, we'll have 15 minus 13 is 2. And we can connect this to this part. So we have to invert the signal twice, and in the middle subtract what we want. And so if we decide to subtract 4, it will be 11 here, and here we'll have 4. In our case we wanted to add or subtract 1, 2, 3 and then 4, and I will show you how you can do this. Since it's easier to go from 4 to 1 than going from 1 to 4, we will invert the signal again, and we'll have here this comparator having 4, 3, 2 and 1. And we can have the same thing as this to start the signal strength. Instead of starting at 15, we will start at 4, and then we can go down by having the same system on the side. It's a bit messy, but I added the rest of the system. We start at 5 just because then if we also have 5 here, this will be 0, so now we are adding nothing. If I trigger it once, we will have 4. 4 here, 1 here, and so we are adding 1. If I do it again, then we are adding 2, 3 and 4. And once we reach 0, we'll add 5, but at this point we will have to reset the system to have 4 again, while 5 here, and so 0, and we can start again with this one. So we have to start at 15 all the way to 0, and then once this is 0 we have to use this one and go down to 0 also here, and once this is 0 we can start again here at 15. So this is pretty much the last thing of the logic that we need to add. We need to have a counter depending on the height of the wall. If the wall is 200 blocks tall, since we have 20 steps in the process, we need to have 10 items in the counter. And the other thing we need to add is the red color at the end to select the correct item. I feel like at this point it's gonna be easier to show you in the complete machine how this works. Every time the player places a block, it will trigger this piston to push it, and also trigger the randomizer. It will dispense a box. Here we have the signal strength on the side to compare it. And on this side we have the thing to extend the signal strength, to have it 4 game tick instead of 2. On this part we are inverting the signal strength, so we have 15 and also 15 here, and this comparator is used to add the signal strength. The signal is stored at the top, it's currently at 5, so we have 0 on the side. Then the signal is sent down to this part. This is where we handle the logic and have the output here, which is between 0 and 2. We invert it to have it between 1 and 3. This is where we stop, and this is connected to the red coder. In the red coder we input a signal strength between 1 and 3, and we have 3 slices. If the signal is 1, we will trigger the first one. And this is because this container has a signal strength of 3, and -1 it's 2, and so this turns on the first 2 slices, and here we have 1, and this only turns on this dust. When a block is placed, it also triggers the counter at the bottom, and I'm not gonna go into much details about the counter because it's not my design and I don't fully know how it works. Currently we have 10 items, so every 10 blocks it will send a signal up, and it will trigger this piston to reduce the signal strength that is stored here. It will also send a signal to this side to reduce the signal strength at the top. But here we only want to reduce it once we reach 0 on this one, and so we have a piston that is blocking the sticky to extend. And this piston will retract only when this here is 0. And I'm pretty sure this part is directional because dust is powering the piston, but it's also QC powering the bottom one, and that's why you can't build this in every direction. I hope I will find a fix at some point that still fits inside of the footprint, but for now you can still use it, and you can easily change the direction of the wall, so it's not a big deal. And once the top signal reaches 0, it also triggers this piston to reset it, and it triggers this one with the torch to send a signal strength of 15 to the one at the bottom. I hope this part was clear. I know it doesn't make a lot of sense when I explain things inside of the machine, that's why I tried to explain it before. And here everything is really compact, so it's not easy to understand everything that's happening. There is one last thing that I didn't mention, and it's this part, because we have a slight issue that the signal is constant, so it's always on, and we want to have it turned off for the red coder to work. And so we have to cancel the comparator for 2 game ticks every 6 game ticks. And I can show you if I add an observer, the comparator will not detect it. Even though it's a signal strength of 15 arriving, it will not work. If I have, for example, a dust, it also won't work. And I think it's because you need to prime the comparator. I don't fully understand how it works, but I know you can make it work by having a block and another observer, and you can have another block here and the observer here. And if you trigger this, now the comparator will turn off. But there is now another issue with the observers, is that if you, for example, have another one here, it will still work. But if you have this, then it doesn't work. Even if you remove this observer, it only works with the player input. Or you can switch the node block with a piston, and in this case it will also work. And Nurse showed this to me. He said he's gonna maybe explain it at some point if you have some time, but it's due to some weird mechanics of the observers and also comparator in this case. In the complete machine I have it vertical, but it's still the same, and it's triggered when we place a block. This observer will send a signal to this piston, and then it will trigger this. And again, we need this piston. It will not work with a node block or trapdoor or something similar. Now I'm going to show you how you can use the machine, and first I'm going to talk about the placement. If you want to have this type of gradient, the height of the wall needs to be a multiple of 20. In this case it's 200, and in our case it will be 100. If you go at the bottom block, in our case it's -63, it needs to be 100 blocks from the blue glass here. And here it's 37, so it's 100 in total. In this case, 100 divided by 20 is 5, so we'll need to have 5 blocks in the counter. And also make sure to not rotate the machine because it's directional. and as far as I know is due to two reasons. Here the two pistons are triggered at the same time, and depending on the direction this one will extend first. And this dropper is QC powered by this observer, and on certain direction this dust will update the dropper at the wrong time, and it will make the observer trigger more often, and then this piston will be constantly clocking. Then you can input the shulker boxes at the top. The first color will be on this side, so here we'll go with red, orange and yellow. And then the items will start going here, and you will need to make sure at least all of them are full if you want to start the machine. Then of course you have to extend this for the entire length of the perimeter. I have an example here somewhere in the world download, and you can see how it looks for 272 perimeter. Once the schematic is correct, just make sure all the inventories are also correct. You need all the 15 boxes here, and it doesn't matter in which dropper dispenser they are, just need to have the 15 different signal strengths. And in the barrels you need to have 4 stacks here, 15 here, 15 on this one, and 12 on this one. And also make sure these droppers are all empty. Then you can grab 4 blocks of the first color, in this case the red, and you need to stand on top of the red glass. Make sure it's in your first slot, and make sure also to be in survival if you're testing the machine. And then you need to do player, use, interval 6. There is a buffer here because it takes a bit of time for the logic to kick in, so you can remove those blocks once you're done with the wall. And here we can see the machine in action, and it's creating the gradient. And now the first slice is done, it will start the second one. And so that's it on how to use the machine. The only downside of it really is that you can't pause it and start it again. If you have to stop for some reason, with this type of gradient, what you can do is reset the slice, so you start with a new slice, you also remove the blocks that are in the conveyor, and you reset the machine. So in this case it will start from 0, but if it's a new slice it will be the same, because each slice is the same. The only problem is then if you have a different type of pattern, then some of them you can't really start, or there is a good chance they will be messed up. Okay, now I want to show you other patterns that you can make using the same machine. In the beginning I've shown you a few, but here I'm going to show you even more. The first obvious thing is just to change the colors. Here I have different gradients, from darker colors to lighter colors at the top. These are just some examples, and I'm sure you can find a lot more. But you can also change how many blocks you have in the counter. So here instead of having 10, there are 20 blocks. And so each gradient will take 2 slices. And so this can create some interesting patterns, especially if you switch the colors. In this case, we have 2 black and 1 lime, and this kinda looks like the thing in the Matrix. Here we have black, blue and black, and in this case it's red, red, black. All of this will be in a world download if you want to check. Instead of changing the counter, you can also change the height of the machine. So instead of having 200 blocks, you can have 202 or 205. You can add or remove a few blocks. In this case, I added 2 blocks, which created this diagonal pattern. So it's the same gradient, but moved by 2 blocks each time. And it doesn't look amazing with these colors, but if you change the colors, you can have some interesting things. Like this one, or well, this, if you like this combination of color. And of course you can also change the height and the counter, which makes for pretty interesting patterns. In this case the counter has 20 items and the machine has been moved down 2 blocks. I think my favorite among these are either the simple gradients or these ones, which I really like. But I'm sure there are a lot more possibilities that you can do. You just have to play around with the contours and the height of the machine. I'm sure you can find even more interesting patterns. Before ending the video, I want to talk about different modifications you could do to the machine to have more than 3 colors. In this case, I tried something to have 6 colors, and the idea was to have a gradient between the first 3 colors, then have another gradient between the next 3, and start over with the first one. And I have an old prototype of the machine which does that, and it even had black concrete between the two gradients. And I tried to do it with this machine because the old prototype was a lot bigger, and something's not working. I can't figure out what exactly is not working, but every time we switch from one gradient to the other, it misses one block, which stops the machine. And the logic to have more colors is we still have between 0 and 2 here, but instead of 3, we have 6. And so if this is 6, we'll have between 4 and 6. But if we also remove 3 on this side, we will have between 1 and 3. So depending on if we remove 3 here, we will have either 1, 2, 3 or 4, 5, 6. That's why I connected the top part. Every time it reaches 0, it will send a signal and move this comparator. But when I do this, I think this comparator gets updated and it doesn't turn off properly. That's why we're missing one block, which stopped the machine. And I added a 0 tick, so the retraction and extension has the same delay, but even this is not working. So I will continue to investigate and make this work, but it's been a while and I really want to have this video out. And it's also possible to add more colors if instead of having either 0 or 3 in this comparator on the side, you can have between 0 and 12. And you also need to have 15 here. But the issue then is you can't really make a good gradient with 15 different colors, but you can still make interesting patterns, I think. And just as an example, I'm going to show you the different patterns I was able to make with this machine. This one also has the black stripe between the two gradients. We have these two, which I really like, and you can also make these ones. And this is a gradient using 6 different colors. But the thing is, we don't have enough gravity blocks that have different colors, so the gradient isn't really nice looking. Okay, so that will be it for the video. I hope everything was clear. If you have any question or any issue, you can ask in the comments or in the Discord server. If there is any updates on the machine that uses more color to make cool patterns, I will let you know on the Discord server, and I will also probably make a video about it. So thank you everyone for watching, and I will see you in the next one. See you!